I'm one of the solution architects in data and AI space at Microsoft. Just about me, I work in areas of application development, data warehousing, databases, and artificial intelligence space, combined for over 15 years. I am a data science professional with expertise in R programming. My areas of expertise and interest include Spark, big data, NoSQL databases, deep learning algorithms, statistical analysis, forecasting, containerization, etc. So please do reach out to me if you have any questions in these areas. Attached to my profile, LinkedIn profile, you can go and check out my profile. Today we'll be spending like first couple of minutes maybe on Azure service updates, and then we will go through today's topic, which is how to do end-to-end data science using Microsoft R Server, Microsoft tooling, and open source technologies. Is today's demo, I would say. I'll show you a couple of slides. That's about it, and we'll go into the demo. I'll try to keep demo at 300 level, but if anyone have questions in the end, I would prefer to take questions in last 5 minutes. So as far as Azure updates are concerned, we have these updates.
Hey Shri, sorry to stop you. Hey, we are not able to see your screen.
Okay, so let me actually go ahead and share my desktop. That way, everyone should be able to see everything. Yeah, please let me know if now you see a blank screen too. Any better?
Yes, we can see your screen now.
Perfect. Sorry about that. So as far as Azure updates are concerned, last week we have actually updates on data catalog where there are enhanced permissions provided, so that we have fine-grained privileges on who can update the metadata and see the metadata, so on and so forth in the data catalog. And then also we added support for relationships and related data assets, so that we can see those relationships in a better way. So then Azure Event Grid is in public preview. We can actually generate scripts using MS SQL Scripter from Azure Cloud Shell. That is there now. New capabilities for diagnostic settings in Monitor. Some of the batch updates you can read by clicking this link. But one thing I saw very interesting, there is a post from Corey Sanders on investing deeply in Terraform on Azure to actually better integrate DevOps related stuff. So I would encourage you guys to go and check this link. So these are not the only updates. There might be other updates. Please feel free to check out the blog or Azure updates, and those links are posted in the last slide. So coming to R Server, which is coming to end-to-end data science development. So Microsoft probably is the only company as it stands today where there is no known competitor for providing various tools and technologies, especially in the areas of R Server and Python, where a developer or a data scientist could sit together, take up a project and finish end to end, like in a matter of week versus many weeks or months that used to take before, and have that fully deployed production model, which I think is very, very cool. And Microsoft invested so much money and time in this, and I hope every architect pass on this information to all of our customers to take advantage of this wonderful service. So there are various flavors of does anyone have any question?
No, I think you can go ahead. Hey, Shri, we can't hear you. Hello. Hey, Shri, can you hear us?
Are you able to hear me, guys?
Yes.
Yes, now.
Are you able to hear me?
Yes, now. Are you able to hear us?
Yes. Yes. There is obviously looks like some problem. Is my screen still sharing?
Yes.
Okay, awesome. So in the interest of time, please ping me if you are not able to hear me. So let's jump and go further. There are 7 flavors of R as they stand today. Probably we might add more in the future, or we might enhance the existing services. But some of the important things that you might need to pitch to your customer is we support our server both on Linux platforms, Windows platforms, R open, which we call MRO, and the tooling for Visual Studio is free. So anyone can use that. But when we go into the R server component, whether it is on the SQL server or whether it is on HD Insight or on Teradata, you pay for the service. It's a commercial service. With that, you get scalability, operationalization, so on and so forth. So especially the scalar functions help us to utilize all the cores and utilize the memory much more efficiently rather than doing on an individual developer's laptop. So you are still with me, right? Are you able to hear me?
Yes, we can hear you, Shri. Go ahead.
Okay, thank you. So this is probably the last slide before we jump into the demonstration. So this is how involved, right? Because a productionalization might not happen only with a data scientist. Not all data scientists are developers, not all developers are data scientists. So a data scientist develops a model using Microsoft's Visual Studio tooling. We have entire tooling which I will show you. Once they are satisfied with the model, they publish the model to an R server. So once the model is there in the R server, another data scientist can go and get that service and do whatever they want to do on that, which is very easy. But that's not productionalization, right? Using a one-off process from an R server is not productionalization. That's where developer comes into picture. So developer enables applications to reach the R server using REST calls. Any application can communicate with R server, and developer could integrate the models that are developed by data scientists to score them in the real time utilizing these REST API calls from the applications. So for which we use Swagger APIs, we see those. So just from this slide, the key takeaway, which I am going to repeat at the end of the call again is, so data scientist does certain tasks, developer do certain tasks. At the end of the day, we have a full-fledged product that can be utilized by any customer in a matter of 1 week. Okay, so that's the motto of today's demo. So let's go ahead and jump into demo for next 10 minutes, and then I will open for Q&A. So we start with an end product, and we'll see how that end product came. So I'm a developer. I'll call out a specific role, right? So I'm a developer. I'm testing some web application, okay, on my on-premise. So what this web application does is, this is a simple forecasting application I have created on Azure. This is powered by Azure, but I'm testing from my local host. So it takes 3 parameters. So in real time, let's say, I'm just making up names. So let's say a fast food restaurant is restaurant's manager is trying to forecast the sale for the next week, let's say. So he inputs a store location. Let's say he inputs a store location 5, and then let's say he wants to see the burgers, right? So the items queue for the burgers is 1. He want to see let's say a chicken burger, the spicy chicken burger, how much would be the sales in his area or whatever for like 12/28 2013. So I have been training some old data, so pardon me. So think that as like, let's say the next week, right? So let's say you do the forecast, the forecasted value, and the forecasted value here changed, right? So though this is a simple web application that you are seeing here, there are a lot of components in this web application so that someone can go log into that application, see the forecast for the next week. Okay, so this is the final product. So this product can be deployed on Azure web application, just like it is shown here. It can be deployed on Azure web app. This is completely Dockerized, like you see here, right? So these are the various forms of applications that are forecasting applications that are running, right? As a developer, I can test from my local machine, do all the deployment, so on and so forth. So how did I do it? Where all this started? This all started with a data scientist who is working on Microsoft Visual Studio, right? So I have to create first a forecasting model. So this is the forecasting model. I am an R programmer, right? So developer doesn't need to know anything about R or N, right? So this is just an R program. I created an R program. It's a black box. Just don't worry about it. The intent of this session is not to teach R to anyone. So all it does is, all you have to know from this is, as a data scientist, I trained my model. I trained with training data. I tested my model, and my model is ready. So I have used something called ARIMA model to forecast. So that's beyond the scope of this conversation. So let's say I did a model, correct? So then from the slide, what you have seen. So the data scientist, as a data scientist, once I'm satisfied with my model, I got to deploy that model as a web service to Microsoft R. So now I need an R server, correct? So one of the Azure admins in my organization have gone to Azure. Are you guys able to see my Azure portal now?
Yes, Shri.
Okay, perfect. So this is my Azure portal, right? So this is my resource group. So in this resource group, as you can see, someone has deployed an R server for me. So this R server is running, it can run on, we already have seen, it can run on a Windows machine, it can run on a Linux machine, it can run on a HD Insight, or it can run on a Teradata. But for all practical purpose, it's just a virtual machine. So what data scientists have to do is, they have to go and publish the model to this R server right from the Visual Studio. So go to the Visual Studio, they will actually, like write one more small app, right? So it doesn't take a rocket science for a data scientist to write these 5 lines of code, right? This is like any other R function. It's a publish service. The name of the service is forecast service. So what they do is, they are saying these are the inputs, these are the outputs, and the version. Okay. So also I said, Once you publish this model, it goes to the R server. Another data scientist can consume this model. And again, it's not a rocket science. That other data scientist, all they have to do is, so this is my forecast service, right? So let me actually first remote login, right? This is the first command I need to run. So let's say I remote login, I give my credentials. Okay, see the remote tab here. Now I remoted into the R server, and guess what? What is this? This is R terminal. So if I want, I can publish, do whatever I want in the remote session, which is running on the R server. So this is the same Visual Studio. Now no more I am using my local machine. This is this is a remote machine, and I can see the remote workspace. I can see everything from remote, and do and execute the scripts in the remote machine and so on and so forth. Also, I can publish a service, I can consume a service, and I can generate Swagger file for that service. All of that stuff I could do. So let's say I am another data scientist, right? So I will just go and I will say pass this remote thing. Now I am on the local. Already I published the service this morning. I don't want to mess up the demo. I'm not going to republish, but however, I want to get the capabilities of the I want to get the service and see, because I want to see the service. I'm another data scientist. I want to see the service. So if everything works fine, voila. Guys, what does it take? It takes just one line of code for a data scientist to get a service that is already published by another data scientist, right? So what is better? It takes one more line of code for the data scientist to get a Swagger file for that. And now I am providing the Swagger file I have generated here to my developer. As a developer, all I need is a Swagger file. Once I have a Swagger file, I will productionalize this. So as a data scientist, again, I'm going to repeat, once I am satisfied with my model, I am publishing that model. Then other data scientists can consume that model, and they can not only consume that model, they can run with their own parameters, another data scientist, and they can get whatever the result, right? So you have seen me in the website, you pressed 5, I pressed 5, I pressed 1, I changed the inputs and I ran that, and let's say the result, and I got a result, and I got $106,288.40 that you have seen here. So the same 5, 1, and this 106,288 that you see here, both are same. So, but the only difference is this is productionalized, this on Azure websites or wherever by a developer. But in the Visual Studio, another data scientist is looking as in form of an R function, because that's all they know. So we have end-to-end tooling, right? So then last but not least, once the developer gets a Swagger file, developer can run a simple Node.js application, right? So they could write a Node.js application. So if we go here, into this Node.js application, you can actually see my app.js. It is written, like I'm not going to the code. Again, the point is not to teach Node or anything here. It's a simple Node.js application. I have provided routes. I have written the model. If you see the model, the routes are provided so that it can read, it can actually read everything from the R server. these are the routes. It is reading from the R server. This is the backend for that. I not only did that, I Dockerized it, right? So what is all this? All this is done in Visual Studio Code. Remember this, I'm making this statement and this holds true. The number one open source editor as it stands today that is used by fellow developers proudly across the world is Visual Studio Code. Even Google developers use that. The reason is it is such a great product. Everything can be done right from here. If you type Control Shift Tab, you can execute Docker commands right from here. You can go to the terminal. You can do whatever you want from Visual Studio Code. So this is another cap in Microsoft's feather. So everything you can productionize from here. So
hey Shri, while you're here, I can see a couple questions in the chat window. So the one is from Sanjeev. The question is, where was the script R deployed such that it is available as a service endpoint?
Hey Shri, let me qualify that question a little bit. Can you hear me?
Yeah, sure, I can hear you, please.
So one of the great things about R is you can snapshot, right? Like as data scientists are developing models and they have like a stable version, they snapshot and they deploy that. Then when they refine the model, they deploy another version of that, the model that you've built.
Mm-hmm.
So is there a CI/CD pipeline such that this can be pushed via an API and not copied manually? So you see your predict values there, so that you can have multiple versions of that predict values.
Yeah, that's so yes, you cannot as a data scientist do that from this terminal, right? So for example, if I push this as version 2.0 after I change, you can just simply change this to 2.0 and consume that, but that's very inefficient, right? So my CI/CD pipeline is here. So what you do is as an enterprise, there will be another Swagger file for that, right? So once you have that CI/CD process set up, then all I have to do is I have to go to, so all this code actually is in GitHub, okay? So even now it is CI/CD process is enabled on this. So the moment someone changes the version there, I posted actually the GitHub links at the end of this presentation, and you can even see my blog. So later on tonight I will blog how to do that. But the thing is, right, so everything is here in GitHub, okay? So scoring app. So what you can do is, if you change something here, if a Swagger is changed, if you change something here, you git add, git commit, and you see here this line of code that says git push Azure scoring app 1 master. This Azure score app 1 is the Azure web app running on the Azure. I enabled my Git repository to remote into this. So whenever I do this, so automatically right from here, it pushes. Right now everything is up to date, so nothing happens, but something were to change, then you can push it and the app will restart, and within 1 single second the web app which I want to show you here, the web app here will be changed, because the web app here, Azure web app here, is directly integrated with GitHub, and right now it has CI/CD enabled on this. So that's the reason, right? So in the slide which we have seen before, one of the big reasons this entire Swagger thing came into picture is data scientists can only do some things, but all the productionization that happens here using REST calls, CI/CD, everything has to be done by the developer using the Azure Web Apps, Node.js, Swagger, and everything. So developer uses Swagger, Azure Web Apps, Azure, Docker, Visual Studio Code, Node.js, right? So these are all the technologies developer use. But as far as data scientists use, they use just the R server and the Visual Studio. So if they have Visual Studio and the R server connection to remote, that's all they need. Everything they can do there versus here? That's a great question, actually. So I'll stop my demo here. So last couple of minutes or 2-3 minutes, if there are any other questions I could answer. And if you go through the slides later on, you have my blog, and if someone needs something else, I could blog about it later on. But my code and everything, models are there in the GitHub. So don't worry about that. You can always take the code. That's not important. So any other questions? You said there are a couple of questions, so let me go ahead and see in the. Where was the script.r deployed to? MRS such that it is available as a service endpoint. Yeah, so these are all related things, right? So yeah. So anyways, so then let me wrap this up. So to wrap it up, just in a single sentence. So the biggest sales pitch for the customers from our side should be, right, and it is proven and unequivocal. So Microsoft has the product, especially Microsoft R Server combined with Visual Studio tooling and Azure web apps. We have a complete comprehensive solution. Previously it used to take like something like 3 to 6 months to a year. Right now you can actually quickly spin up an R server, whether in a SQL server space or Teradata space or HD Insight space or a standalone product, and quickly connect to that. Data scientists can start publishing back and forth in a single line of code, and developers can use the Swagger API that is generated in order to productionalize that Swagger API as a C# code or Node.js code, and deploy it as into a Docker container or into a Linux machine or on Windows machine running on the Azure web apps. So we cannot get to emphasize, we cannot get any better end-to-end solution with any other competitor of ours. So that's all I'm going to say on this product. It's a beauty. So in subsequent calls, I would spend some time later on to go through how to productionalize in SQL Server, Teradata, HD Insight, and all that. So that is out of scope for this presentation. And thank you all for attending. And I am concluding this. Back to you, Siraj or Naveed.
Yeah, thank you, Shri. This was a great presentation. I can see a couple more questions if you would like to take a look at your chat window.
Oh, really? Okay, so let's see. So R server exposes a web API via Swagger, and the developers build Azure web apps with a UI, etc., and consume the R server Swagger API. Yeah, along those lines, that's correct. Yeah, once you dive into details, yeah. So I agree with that comment. How can we convince data scientists to change their R Studio environment to Visual Studio when they can publish their model using Azure ML and publish their code in R Studio with Git? So, well, there are a couple of nuances. One is, do remember that Azure ML, the Azure ML, Azure ML Studio, whatever you want to call, all are synonymous, is an entry point. It's not a production grade stuff. Okay. So in most of the cases, Azure ML Studio, it can actually, it is an excellent product for data scientists to wrap their brain around various different models. We have like 60-80 models over there. Play with them, figure out what is the best model for the sample data set and all of that stuff. But when it is a good starting point, but let's say your customer matures after 2-3 months using Azure ML Studio and related services, then the next step for them to graduate is to R server. because remember our server, what I did not show you today is it's not only the straightforward algorithms, right? It's Microsoft ML, where we have deep neural network algorithms that are combined with the GPUs, and the CNTK, which is Microsoft's equivalent of TensorFlow, which you would have heard. So all of those are possible. Those are serious production grade stuff that can be done with massive amounts of data, and you do need R server in that case. Okay, so that's the point you need to convince your users. You need not convince; they will understand after a couple of months. Then yes, yes, Brandon. So all of those are true. Yes, you can do all that stuff. Yes. Also, right, to your second question, why Visual Studio versus R Studio? Um, Visual Studio is end-to-end product, right? My organization, I don't need to use 100 different products. In Visual Studio, I have everything that R Studio can do and more. So if they want to use R Studio, they can continue using that. I will never say no to anyone who wants to use open source. They can use whatever they want. But I would strongly prefer you stick with our stack end-to-end. I hope I answered the questions. You can actually, reach out to me in the interest of time after this call. All my information is there. You can reach me on Facebook, LinkedIn, whatever, and I can actually, talk with you over coffee or something, more details.
All right. Thank you so much, Sri. Yeah, thank you everyone for joining. We will be uploading the recording and slides on our channel line. I have pasted the link in the chat window. Hopefully you'll see that by this evening.
Awesome. Thank you, guys. Thank you very much. Have a great weekend.
Thanks a lot.
You too.
Yeah, thank
Thanks.
you. You too. Bye.